I'm
Mm-hmm.
going to start recording now and take it away, Mr. Yun.
All right, here we go. Well, thank you for having me tonight. It's really an honor to speak for yet another user group, so I'm really excited to be here. A little bit about myself, you can read everything up there on the screen, but one thing that I kind of like to point out, particularly in the context of this presentation, is that I am a SQL Server developer. However, I used to be a SQL Server DBA in a previous life. The reason I like to point that out is that I find myself in positions nowadays where I act as kind of the liaison and the bridge between development teams, .NET developers who may write some SQL, and DBA teams. And, I try and teach them and help them out, et cetera, et cetera. The reason I bring this up is that at times it may sound like I kind of, speak negatively about developers, if you will, throughout the course of this presentation. But the reason I bring this up is that I got to remind you guys that I'm also one of you as well, if any of you are developers out there. And because of that, or the other side of that is that there were times in my career where I didn't know this information, and I made some of these mistakes as well. So, don't feel bad about it. Don't feel like I'm harping on developers because, again, I'm also one of you. So enough about me. You don't really want to know about me. What you want to know about are data types. So let's move on. So when was the last time you looked at a brand new database? Maybe you started a new job. Maybe you brought in a new vendor app and you started poking around their particular database. And you saw data types and these kinds of fields out there that just didn't sit right with you. Sure, an address can be stored in a NVARCHAR max, or you could store a zip code in an integer field, but something about that just isn't right. But you weren't exactly sure how to, give a full technical, explanation as to what's wrong with these. Or how many times have you fielded questions like this? Why can't we just use NVARCHAR 255, NVARCHAR max everywhere? What's the big deal? They're just data types, right? Well, I'm here to tell you something else. So hopefully after today, after my presentation tonight, I want to arm you guys with the information and knowledge and some SQL Server tools and scripts so that not only can you better answer these questions and explain to your colleagues, hey, maybe we should be making different types of data type choices, but also some tools so that you can actually go and assess your systems today, or tomorrow, I should say, and find out, hey, are there any data types in my current schemas that really aren't ideal? Let's take a look and see, what I can do better. So the first thing I like to talk about is internals. I'm a big SQL Server internals junkie, and it's my personal belief that everyone should have at least a working knowledge of internals, much like, say, an auto mechanic, should have a really good working knowledge of his engine, of an automobile engine, just so he can squeeze a few extra horsepower out of that engine by, tweaking it and whatnot. And in the same way, we as SQL Server professionals, by having at least a good working knowledge of the engine, can squeeze, just a little more performance out of it. So we're going to talk a little about internals first and how data is stored. So first of all, we're going to be using this simple employee table. It's a pretty typical kind of table. Let's pretend that this is a US-based company for the context of our presentation today. And you can see that there's some, the different data type choices for a lot of the different data columns that we have in here, which are pretty typical of an employee table. We have an employee ID that is using a GUID. We have things like Social Security. We have salary, date hired is a date time. We have some bread trail or breadcrumb type columns of when various records are created and whatnot. So the first, kind of rhetorical question I want you guys to think about and ask yourselves is this: when this table is created within SQL Server, are all the columns actually created and stored in the exact order that you declared them in this create table statement? The answer to that is no. SQL Server actually somewhat reorders the columns into something called the fixed var format. The fixed var format means that fixed with data types come first and variable data types come second. But which data types are fixed width and which ones are variable length? Here's a condensed chart of some of the most common data types, and you can see that actually a lot of them out there are actually fixed width. Earlier on in my career, I mean, this is something I never really thought about or cared about, but as a consequence, for example, with a fixed width data type, that fixed width data type will always require the same amount of storage no matter what the value you store in there. So for example, with an integer column, if I store the value 0, or if I store the value 5 million, or if I even store the value null, it will require the same amount of storage. The null one is a very interesting point. So the question is, though, how much storage? Let's take a look. So you see that between some of the data types that we saw on the previous screen, here's the number of bytes that each of these require. So like I said, with the integer example, it requires 4 bytes, no matter what value is being stored in that integer column. Even if it's null, it will still consume 4 bytes. A couple of interesting takeaways from this particular slide that I like to point out is the difference between the CHAR columns and the NCHAR and the NVARCHAR columns. Notice that it's N, which is the number of characters, times 2 for the N columns. The reason that is that NCHAR and NVARCHAR allow you to store Unicode characters, such that if you're, say, having to store Chinese characters or things that are outside of the traditional English alphabet and whatnot, require twice as much space. It's N times 2 bytes. So if you're never going to store Unicode data, if you're only storing, say, internal code values, or this is a US-based application or a set of data, don't bother using an N data type because you're going to require twice as much storage. It's a huge waste. Use a CHAR or use a varchar. The other interesting thing to point out is that with the 2 variable width data types, we have an extra 2 bytes of overhead. I'll point out what these 2 bytes of overhead are later on, but the thing to keep in mind here is that if you have a column where you're only storing a few characters, a char 1, a char 2, or a char 3, or a varchar 1, varchar 2, or varchar 3, you may actually be better off from a storage perspective just instead of using a varchar, just going with a char. A char 1, after all, will only be 1 byte of storage as opposed to a varchar 1, which will be 3 bytes of storage. Something to keep in mind. So let's talk a little bit about the fixed var format. This is what the fixed var format actually looks internally within the engine. The first 2 bytes of any given record are the tag bytes. They store some status bits and some other metadata about this particular record. And then afterwards, we have 2 bytes that store the total fixed length size. Afterwards, we have the actual fixed length data. And then afterwards, we have 2 other interesting columns. One is the total number of columns in this record, and the other is the null bitmap. The null bitmap has 1 bit for every single column in the table, regardless of whether it is a nullable or a non-nullable column. SQL Server uses this as an optimization because the thing is, null is a different unknown value, if you will, or lack thereof, versus say an empty string or an actual, say, value of some sort. So what SQL Server does is that if you're doing some kind of null check, it'll actually go to the null bitmap first and then see if, oh, hey, is this bit on or off for my particular column that I'm querying against? If it's not, then I move along. Or if it is null or not null, or whatever the case may be. Now, if our particular table has no variable length data columns, we're done. However, if we do, then we have the variable count, which is the total number of variable length columns, the variable offset array, which is 2 times the variable count, and then the var data. This is where the extra 2 bytes of variable length overhead come into play, because SQL Server actually needs to essentially dynamically do the math. We'll see an example of this in a moment. First, let's see an example of some fixed length data. So let's pretend we're just looking at these particular 5 columns here. So in here, the total fixed data size is 144, and then you have your employee ID, your gender, et cetera, et cetera, et cetera. So SQL Server can know that, hey, when I'm actually looking at this, when it's looking at a pointer on disk, if you will, if I need the social security number, I know via the data types how many bytes I need to jump in order to actually pull the social security number or the date hired. it knows, to do based upon the data types, it can do the math and it can just immediately jump to my exact value. On the other hand, with variable with columns, let's look at, say, title and email address. Here's an example of one record with the value president and the value L accounting bytes. Each of these have different variable lengths. So therefore, and they're currently declared as NVARCHAR, so therefore we have the variable length offset value 18 or 40, so that SQL Server knows that if I want to get to the email address alcountingbytes.com, I got to start from here and jump up 18 bytes because I've looked at my variable length offset. Same goes if I wanted to do that on the next record and get James at countingbytes.com. I see that the value beforehand, the variable offset, is 44. So SQL Server can then do the jump. In the days of old, when we had far, far less powerful CPUs, people would say, things like, variable length data types, cost a lot more CPU overhead. You should use them sparingly, yada, yada, yada. This is wisdom from maybe 20 years ago. Our CPUs today, this is so trivial it's not even funny, so don't even think about it. But yes, SQL Server does have to do just a hint of extra work when you're dealing with variable with data columns. So, knowing what we know about fixed with data columns, at least, we know that no matter what values are stored in there, we know that they require a minimum amount of storage, right? So therefore, regardless of what we are actually storing in a given record, we know that each given record will require a minimum amount of storage no matter what the values are within them. What is that minimum amount of storage for employee large for one record? In this case, it's 1,300 bytes. Now, we live in the day, today of gigabytes and terabytes. So 1,300 bytes doesn't sound like much, but that's one per record. And how many people here deal with tables that have 1 or 5 or 10 records, as opposed to tables that have millions, hundreds of millions? This adds up fast. So the thing is, with 1,300 bytes here per record, I argue we can do better. We can do much better. How? By right-sizing our data types. What do I mean by right-sizing? Well, when I say right-sizing, it's kind of it's both an art and a science of asking yourself the questions of, for each particular data point that I'm storing, what is a more applicable or appropriate, say, data type, or I like to also think of it as a container, if you will. For example, am I going to be storing numeric values such that with an integer, I may ever only go up to a couple hundred values or even a few thousand values. Do I really need an integer there? Can I just get away with a small int? I can shave my storage in half from an int to a small int. Or a lot of people default to using datetime. I'm honestly guilty of doing that myself. But what if I don't care about the actual time value for whatever I'm storing? I can shave off 5 bytes. Over half of my storage, I can shave that down by jumping down to a date data type. So to kind of, ingrain this a little bit further, let's do an exercise together. So since I can't really talk to you guys directly, I'm going to just ask you guys to think about, with Social Security number here, it's in our original employee table, is defined as an NCHAR 50. What would you choose instead? Would you choose a date data type, some kind of number, or some kind of string? Think about that for a moment. Normally I'd be asking, getting feedback if I were live and in person, but hey, at least I'm here. So in either case, I would say let's go with a string. Again, we're going to pretend that our company and our database and our system is a US-based system. We're not having to worry about international values of some sort. So knowing that, what will we then choose? CHAR, NCHAR, VARCHAR, NVARCHAR. In this particular case, I would argue that we should choose CHAR 9. I would say that, or I'm going to pretend that the application that consumes this data would insert the dashes for us. Social Security number is always, 9 digits otherwise. If, for example, we did not have an application that could, do the formatting for us and add in the dashes, and our requirement was that we store the full Social Security number with dashes, I would choose a CHAR 11, for example. But in either case, I've gone through the exercise of asking myself these questions. How about this one? Vacation days remaining, integer. If you work for a company where you could actually even start to approach the higher end of an integer as far as vacation days remaining, I want to work for you. So in either case, what do you think we should be using here? Date, number, or string? I'm going to say we're still going to want to use a number. So here's three options for you: tiny int, small int, or decimal. Now here's the thing. Some of you guys may be saying tiny int, some of you guys may be saying small int, some of you guys may be saying decimal. I'm going to say decimal. The reason for this is that I personally happen to work for a company that allocates or you accrue vacation days on a per pay period basis. So every pay period I accrue 1.44 days of PTO. So a system that uses an integer could not support my payroll system. Or, for example, tiny int, some people may have opted to do that. But remember, with a tiny int, you can't go negative. It only goes from 0 to 255. Are any of you allowed to borrow against your vacation allocation for a given year? Say, for example, if you accrue 2 weeks over a full year, but, say in the middle of the summer, you haven't accrued that full 2 weeks yet, but you're allowed to take 2 weeks of vacation because you can borrow against what you'll get for the remainder of the year. So you're going into the negative. So in your case, or that case, you could not use tiny int. The point is that you need to ask yourself, for your business and your application, what data type would work best for your needs, and that's right sizing. So now that we've kind of understand right sizing a little more, I've gone back to the employee table and I've created a new employee table called employee narrow. You see that, for example, I've gotten rid of the unique identifier GUID as our employee ID. I've done some other things, such as with date hired, I've made it a date column now because we don't care about the time that you were hired, for example. Things like our record created date, last modified date. I don't care about millisecond precision as far as when this record was created, and things like that. So with these changes in place, how much minimum space do you think each record will need? In this case, 104 bytes. Remember what employee large was? 1,300 bytes. That's a factor of 10. That is huge. Storage requirements by a factor of 10. Now, sure, this is an extreme example, but nonetheless.
Andy,
yes.
We froze for just a second, so can you go back?
Okay.
So you were saying we started with one value and you shrunk it to another value. So just repeat that.
Say again.
The original size of the row versus the.
Oh, right. So knowing that a given row in each particular table requires a certain amount of minimum storage, we see that now that we've right-sized the employee table, at minimum, employee narrow now only requires 104 bytes, as opposed to employee large, which required 1,300 bytes, and that's a factor of 10. So I was simply making the point that if you're a DBA, how many people want to tell their boss that, hey, I can shave off our storage requirements by a factor of 10. It could be potentially huge. This is a rather extreme example for illustration purposes, but nonetheless, you could probably go back to your own systems, take a look around, and shave off a good amount of space here and there. So we're going to jump into a quick little demo. So first of all, I'm going to talk a little bit about SP Help, and then I'm going to talk about...
Question.
Yes.
Hold on. How did the employee ID get down to 1-1? Can you go back?
Yes. So employee ID.
Yeah, it's just an identity.
So that yes. I switched it from a unique identifier, which is what it used to be, to a auto-incrementing integer. Does that answer the audience member's question?
Is that good, John? Okay, we're good. Thanks, Andy.
You're welcome. All right, demo time. So I have a sample database here called Every Byte Counts, and we have our employee large and our employee narrow tables. I'm just going to do a quick select top 1,000 out of each. just to kind of show that each of these two tables have effectively the same, or not effectively, they do have the same exact data. They have the same 250,000 records. Where things differ slightly is, for example, employee ID went from being a GUID to an auto-incrementing integer, but otherwise, when I generated this data, it all matches up. So I'm going to quickly first use SP-help against employee large, execute that. And SP-help, which is a built-in stored procedure in SQL Server, actually will give you at your fingertips all sorts of really awesome information about your table. Because here's the thing: who here memorizes every single table, in all your various databases and whatnot? I certainly don't. I have a lot to deal with. So there's a lot of times where, like, okay, I remember what's in that table, but what is that data type, or how do you exactly spell that column? Or hey, I need to just copy and paste and grab all the columns out of here for, say, if I'm writing an insert statement or doing something else. So SP-help is a really nice little quick shortcut. You can see the data types that we talked about a bit earlier. If you scroll further down, you can also see other information about a given table. It's really handy for just checking things out real fast. So, for example, you can look at, there's index information down here, or there's constraints and foreign keys that'll show up if you actually have any. Let's quickly look at employee narrow. See some similar information again. We have, instead of unique identifiers, we have, integers, auto-incrementing. You see the identity column here. That's a separate result set of employee ID. The seed value was 1, increment by 1. And otherwise, you have the same kind of information. So here's the thing. Typing exec SP-help for your given table is really kind of cumbersome. And it doesn't make for using it on a regular basis, very easy. However, Management Studio, using keyboard shortcuts, allows you to do this much, much easier on a regular basis. In fact, I do this almost every single day. So to do that, you go to Tools, Options, Environment, Keyboard, and Query Shortcuts. And within the query shortcuts, Alt F1 is the default for SP-help. Control 1 and Control 2 are also defined by default within Management Studio. And then I personally like using the Control keys, so I've remapped Control 3 through Control 7 to some of my favorite stored procedures. What this allows me to do is this. If I'm writing a query in, I'm, say, looking at my, select against employee narrow, and I don't exactly remember what's all inside employee narrow, I can highlight it, hit my query shortcut, bang, I just executed SP-help. Pretty cool. It's nice. It's really quick, and it's right at your fingertips. Now, Andy, why are you showing us something as fundamental or as basic as this? Let me tell you a story. So around the time I was actually developing this presentation, I gave a prototype of it to some of my coworkers. Later that week, we had to do a deployment and a big software rollout, a big overnight affair and whatnot. So and within that deployment, we had a migration script where we had to copy out a bunch of data from a table, do some manipulation against it, and put it into a new version of that table, right? Very typical kind of thing that you see in software upgrades. And of course, the script, even though it went through QA and went through rigorous testing, blew up at 3 in the morning. Why did it blow up? Because my colleague who wrote that script, pulled all this data out of the base table into a temporary table. And when he created that temporary table, he didn't bother to double check the data types. He didn't bother to see that, oh, some of these string data types, what the sizes were. So he just, arbitrarily set up a bunch of varchar 200 columns to store all of the strings. And passed QA just fine, but QA only uses a subset of production data, and we had one column out there that was actually larger than 200 characters, and of course, one client with just a handful of records that exceeded 200 characters. So therefore, when we tried to read out of that table into the temp table, that was a varchar 200, it blew up on a truncation error, which could have all been mitigated if had my coworker gotten into the habit that I've gotten into of when I'm writing things like that, of double checking what my data types are simply by hitting that keyboard shortcut. What do I got in here? Okay, it's a varchar 100. Copy that out. I'm good to go. So that's why I talk about something as simple as using SP-help. And it's also really nice just if you're digging around the system and you just want to get that information really quickly. Who here wants to go to Object Explorer and click through it and try and find your given object? I can just hit that keyboard shortcut and I'm good to go. So the second thing I want to show you guys is a DMV. DMVs are dynamic management views. If you don't know what one is, I think they're the best thing since sliced bread. They give you a really awesome internal look into SQL Server, and there's, I don't know, a couple hundred of them now, if not more. In this particular case, we're going to look at sys DMDB index physical stats in order to get some interesting data points about our particular table. In this case, I'm going to look at employee large. I'm going to be getting the record count, minimum record size in bytes. You guys didn't think I did the math myself. The maximum record size in bytes and the average record size in bytes. So let's take a quick look at that for employee large. We see that for employee large, the clustered index has 250,000 records. We see the 1,304 bytes from earlier in the slide. We see that it has a max record size in bytes as well. And then this is the one that's really useful for if you're looking at your production systems. What is my average record size in bytes? So I can actually take a look at one of my other systems and see how much am I actually really using here, you know, on average, given my actual data. That's where this is really cool. And for a quick comparison, let's just look at employee narrow. Same 250,000 records, 104 minimum, 182 maximum, and then 127 on average. Good metrics to know. So this is just a nice quick little demo just to kind of show you these few tools. Back to the slides. Any questions real fast?
All good.
Going once? No? Okay.
No questions.
All right, so moving on. Ask yourself this. Do you think SQL Server, when it actually stores these records physically on disk, just stores these records one after another? The answer is no. SQL Server uses another container, if you will, called the data page. Now, there's a number of different types of pages within SQL Server, but for the context of this presentation, we're just going to talk about data pages. And there are three types: in-row, row overflow, and lob. All pages have a fixed size of 8 kilobytes, and this is something that will become very, very important shortly. And then, as you can see here from this little diagram, data pages have three components. The page header stores a wide variety of metadata about the given page. Those 96 bytes in every single data page is lost. It's kind of a waste. Excuse me. Data records just get thrown haphazardly into B. I say haphazardly because in C is where we have what's called the record or the slot array, 2 bytes per record, and this is actually a pointer to the actual record within the data page. If you have a clustered table, your clustering key and the ordering will actually be logically enforced here within the slot array. Your actual records will not be ordered on the page itself. The record will just be put in wherever there happens to be space on the given data page. So it's a little bit of a I guess misconception, if you will, when you say that if your table is clustered, that it's actually physically ordered by by your clustering key. Technically, the records really are not. They kind of are, but within the context of a data page, they are not, because the ordering, again, for the records that live on this particular data page are enforced in the slot array. So I kind of want to highlight a few things about the 8 kilobyte limit. In SQL Server, whenever you do any kind of query, SQL Server does not work within records, if you will, when you get records back. It works with data pages. Think of a data page as the minimum work unit, if you will, of how SQL Server works with your data, I/O essentially. So because I/O is executed via data pages, not data records, it's in our best interest to try and maximize the number of records per data page. So typically, almost all of our data will be stored on in-row data pages. 98% of your data pages will be in-row. But as you can see from the next final 2 bullet points, there will be a handful of exceptions. If we have a varchar 8000 or NVARCHAR 4000, SQL Server will instead have a pointer to another data page, a row overflow data page. So if you're using these two types of data, data types, SQL Server actually has to do extra I/O because it has to get your base record, one page I/O, and then it has to get the row overflow page. With varchar, NVARCHAR max and varchar max, SQL Server will attempt to store the value in row, but at which point, if your value is so large that it exceeds the amount of free space on that data page, then it'll push that value off to a lob data page and then create a pointer to that. But if you happen to be using varchar max, but you're only storing small strings in there, you may be safe. So how many per page? Well, knowing the minimum record size, we can calculate and figure out what's our best case scenario. In the case of employee large, our best case scenario is 6 records per page. That's not very many. Whereas with employee narrow, our best case scenario is 77 records per page. That's a heck of an improvement. Why do we care? Well, think about it this way. Think about how much I/O or work SQL Server has to do, how many data pages it has to look through. Even if I've already read all these data pages from disk, it's still in the buffer cache. SQL Server still has to parse all that. So if I run a query like this, where I'm selecting some records from employee narrow, I only have to pull a handful of data pages to satisfy that. However, if I run the same exact query against employee large, which has the same underlying data, I have to pull a heck of a lot more data pages out and process them in order to return the same records, the same data, in order to satisfy this query, all because of a difference in data type choices. Let's look at it from a numbers perspective. Again, how many people work with tables that have 1 record per 1 or 2 records per table? I sure don't. So look at it from when we get into numbers like 1.5 million. The data will require 250,000 pages versus just under 20,000 pages for employee large versus employee small, and look at the size requirements for each of these pages. A huge difference here. Look at it when we get to 25 million. A huge difference in the amount of data page required, or data page and storage required, just because of data type choices. And imagine if you have to do a table scan against those 25 million records. SQL Server has to churn through that much data, all those data pages, in order to do your table scan. So I'm going to do another demo now. We're going to return back to the DMV that I showed you a few minutes ago, and then I'm going to show you something called Statistics IO. Let's check that out. So let's see, user database. And in this, let me get rid of that. In this case, now we're going to expose a few new columns that I did not expose to you before from this DMV. We're going to look at employee large, and notice now I have the page count exposed next to the record count here. It's 41,000 pages. Also, what's interesting is that this particular DMV can show us the average page space used in percent. In this particular case, because everything has been rebuilt recently, I have very good page density. Page density is a topic outside of this, but it's something else that to keep in mind as far as ongoing maintenance is concerned. And then we have the same data points from before. Let's look at employee narrow again. 4,400 pages, a heck of a lot smaller for the same 250,000 records. Huge savings there. So, Statistics IO. I love using Statistics IO, and you can turn it on by simply executing Statistics IO on. I use this all the time whenever I'm query tuning and performance tuning. Because the thing is, when I'm doing performance tuning and query tuning, I don't care as much about the number of records a given query pulls back. I care about the number of data pages that SQL Server has to deal with, it has to read and to process in order to fulfill my queries. And statistics.io shows us that information. So I will run that. So let's query a small set of data. I'm just going to do top 100 out of employee large and out of employee narrow. Execute that. I'm going to go to the messages pane, and we see the output of statistics.io. In this case, I did one scan each, and we look at the logical reads. The number of logical reads is the number of data pages I had to read in this particular case. 35 from employee